Hi everyone, this video is going to be about finding the equation of tangent lines and hence also finding the equations of normals using the derivative function. So that we know that tangent lines are a line that's drawn at a point on a curve so that it has exactly the same gradient as that point on the curve at that particular section of the curve. Okay, so very difficult to draw by hand, very difficult to get them perfect by hand, but if you wanted to find the approximate instantaneous rate of change, great way to approximate it, but really hard to draw by hand and to find that that gradient. But we can use the derivative function to find the gradient of that tangent line and hence help us find the equation of the line. So we know that a tangent line, it's a linear function, linear line. So, and we know that for all linear lines, to find the equation of the linear line, we can use the point gradient formula to find that equation. So that's what we're going to do to find the equation of a tangent line. So y minus y1 equals mx minus x1. So with all linear lines, what we need is in order to solve, we need a point. So we need an x and a y value, and we need the gradient. So there's a number of different situations that we can have. The easiest and the first situation that we can have is if we're given the x value. If we're given the x value, that means you need to still find the y value. And you have to ask yourself, how am I going to find the y value? You're going to find the y value by using the function for the curve. And the function of the curve is f of x. And once you've got your y value, you have to say to yourself, okay, now I need the gradient. How am I going to find the gradient? And you think, well, the gradient is equal to the derivative at a particular point in time, because the derivative is the equation for the gradient along that curve at any point. So if we need m, we need to use the function of the gradient, which is f dash x. So we're going to substitute in there. A couple of other quick examples. If you were given the y value, that means you need to find the x value. And to find the x value, you're going to have to use the function of the curve as well, because the function of the curve, f of x, is the relationship between x and the function and the curve, so x and y. We're going to use f of x. Then we still need to find the gradient. Now, the reason when you're given the y value, you always have to find the x first, because the y value and the gradient have nothing to do with one another. They have absolutely nothing to do with one another. You can't bring them together in any way. So if you're given the y value, you have to go y value, then the x value, get your x value, and then you can substitute it into the gradient function. Might do another video later on that one. So that's going to be x into the derivative. And obviously, then if we're going to have the last thing that you could be given, you could be given the gradient. So if you're given the gradient, you have to think, okay, the gradient has the only thing that the gradient has a relationship with is x. So you'd have to use the gradient to substitute gradient in and rearrange to solve for x. And then once you have that x value, you can find the y value. You can't find the y value until you found the x value, because the m and the y have nothing to do with one another. They have no relationship. Okay, so we'll do a really quick example. Let's look at our nice, basic, straightforward function of fx equals x squared. Let's look at a really basic point. Let's look at x equals 1. Okay, so at x equals 1, on the function of x squared, the first thing we should probably do is find the y value. You know, I always like to write headings. I'd really like you guys to get into the habit of writing headings. Just it makes your working so much easier to follow. Okay, so we're going to find the y value. So that means we're going to be using the function. So you substitute your y value in, your x value in. So the y value is going to equal 1 in this case as well. So we have a 0.11. Cool. Okay, the next thing that we're going to do is to find the gradient. And in order to find the gradient, I need to find the derivative, because the derivative is the relationship between x and the gradient. So if I've got f of x equals x squared, f dash x equals 2x, and if we've got x equals 1, we've got 2 times by 1 equals 2. So therefore the gradient equals 2. So now the only thing that we've got to do is substitute it into our point gradient formula. Write down the formula, fill it in. Equation of the tangent. So that, if we were to draw the curve of x squared and then draw a tangent line at the point 1, 1, the equation of that tangent line would be 2x minus 1. I might do a separate video on normals. A normal is a line that is perpendicular to the tangent. So it just might take a bit of refreshing for you just to remember how to find a gradient that's perpendicular. So I hope that helps. There'll be some more derivative videos coming, so let me know if there's anything on this one that we need to go over anything in more detail, but talk soon.